Hi there, welcome to the second session of Computer and Communication Network. In today's sessions, we are going to deal about fundamentals of data and signals. Before I take you to the this current session, let me give you a quick recap of what we have done in the previous session. In the previous session, we saw what is a computer network, we saw the various elements of a computer network, and we saw what is an internet, how big an internet was. So in the computer network, we saw what are open networks and closed networks, and we also saw what was the necessity of connecting two or more computers together. Now in today's session, we are going to talk about more on fundamentals of data and signals. See, know that data and signals are the integrated part of computer networks, and there are different aspects to learn from it. So we shall discuss on what are analog and digital data or analog and digital signals. We shall see what are data codes, then we shall put some insight onto some important terms in computer networks like frequency, bit rate, attenuation, signal to noise ratio, etc. So before wasting any time, let's go ahead and see what are analog and digital data. Now before we understand what is analog and digital data, you understand what is the meaning of a data. We all know what a data is. Data is an entity which conveys some meaning. For example, if I want to send one message from one mobile to another mobile using an SMS, I'm going to send a 10-digit mobile number, that becomes a data. Now data can be of two types. Either it could be analog data or it could be a digital data. Now what is analog data? Analog data could be your voice data or a video data, and a digital data could be your text data. Now you're all very familiar with analog and digital data because you have been using these kinds of data in your WhatsApp and other social media activity. So I need not stress on these things. Now in order to transfer the data from one place to another place, you need to have a computer system, or you need to have a kind of a system basically to transfer the data from one place to another place. Now have a look at this diagram here. You have got two computers, A and B. Now here computer A is transferring the data to computer B, and the computer B is receiving the data from computer A. So that means that two systems are interconnected with each other. Now this is one of the idea of computer networking in an open system where we can send and receive data. Now in this case, A and B are connected to each other. I mean computer A is connected to computer B, they are interconnected each other, and computer A is sending some data to computer B, and the data could be either an analog data or a digital data. Now can you just send the data from A to B? Is it just possible to send the data? No, you need some way of sending the data. For example, if I want to send an email message from A to B, can I just simply send an email message? It's not possible. I need some medium. I need somebody to carry the data from A to B, and this is exactly what you mean by a signal. Now what is a signal? Signal is basically a representation of data in various forms. So if you want to send the data, you have to send the data in the form of a signal. So you can call signal as a representation of a data. And you have broadband system and a baseband system. So what is a broadband system? A broadband system is a system which is used for transmitting analog data, and your baseband system is a system of transmitting digital data, and the signals could either be electromagnetic or light wave. Today you must have heard of optical fibers. So what is optical fibers? Optical fibers or fiber optics is a way of transmission of data in the form of light, and you know the speed of the light is pretty high, so the data transmission is also pretty high. So today most of the internet basically works on fiber optics, so which means that signals are basically representation of data. So data is actually transmitted in the form of signals. Now what exactly is this analog signal and digital signal? You need to understand this concept very well. So in order to understand the concept of analog and digital signal, we need to take the analogy of a clock. So now we have two types of clocks as shown in the picture here. You have got an analog clock and a digital clock. So most of you must have seen this clock on a day-to-day basis. First let's understand what an analog clock is. An analog clock basically is a clock which basically shows time in the form of minutes, hours and seconds. So you've got three needles there. You have a needle for hour, you have a needle for minute, and you have an hour, and you have a needle for seconds. Now if we have to find out the time of this particular analog clock, you just have to see the time in terms of hour needle, the minute needle and the second needle. Now the time is 10, 10, 25 seconds. Now the second needle keeps on ticking. That means the next movement, the time would be 10 hours, 10 minutes and 26 seconds, then 27 seconds, then 28 seconds and so on. Which means that the number of values given by this analog clock would be infinite. There could be infinite number of values given by the analog clock. You can, if your eyes are able to perceive, you can even perceive the fraction of a second. So which means that analog clock gives you analog signal, and the analog signals are always infinite. Unlike a digital clock where the data is finite. For example, you have 6 hours and 57 minutes. I'm sorry. That means the next data would be 6 hours and 58 minutes, which means that it is not showing you the second part here, which means that the data is discrete. It is not continuous. So analog clock gives me analog signals, and digital clock gives me digital signals. Now going back, I have given you the picture of both analog signal and digital signal here. Now analog signal is actually represented in the form of a sine wave. Now every sine wave will have a positive half cycle and a negative half cycle, and a digital signal is actually represented in form of a square wave. And know that analog signals are always continuous, whereas digital signals are discrete, which means that they are not continuous. Now one more example you can think of this analog and digital signal would be the application of your analog and digital thermometer. Now the analog thermometer gives you the reading in mercury levels, whereas the digital thermometer gives you the reading in digits. Now you can see that the thermometer reading in the analog thermometer is around 37 degrees. Now as the temperature rises over the time, you can see the reading, and you can have infinite number of readings. You can have reading like 37.5765732 if you are able to perceive that particular temperature inside the thermometer. Whereas in a digital thermometer, you cannot have that much precision of data. The first temperature would be 37.5, then it will increment by 0.1, 37.6 and so on. So your data in your analog thermometer would be continuous. You can have infinite number of values, whereas your data in your digital thermometer would be discrete. So now that you have understood the concept of analog signal and a digital signal, and understood the concept of analog data and digital data, you need to understand the different combinations of sending this data over the signals. So signals and data can either be analog or digital. Now we are clear about this particular point. Now how do you transmit this data? You can have different types of transmissions or combination of transmission. You can have a transmitting of digital data using a digital signal. You can have transmitting digital data using analog signal. You can have transmitting analog data using digital signal, and you can also have transmitting analog data using analog signals. So there are different types of transmission mechanisms you can think of. Now that you have understood what are analog data, digital data, and analog signals and digital signals, so we shall try and understand what do you mean by a data code. Now what exactly you mean by a data code? To understand this, we shall take an example of an simple illustration of how two computers communicate each other via email messages. So all of you must have had email IDs. You have sent and received emails. So suppose if you have a Gmail ID and you are sending and receiving Gmail. Now I am sending an email from one system to another system. Now you know that the email is a combination of text. Now it is a combination of multiple text. It consists of characters, numbers, etc. Now I am sending one message called hi within an email, and that message also consists of number of other things which I have not shown it purposefully. Now if I want to send this message from one system to another system, you see that the entire message is converted into series of ones and zeros. Now we call them as strings of ones and zeros. So this is the ASCII code of H, which means that the H has got a unique binary value. For example, the value of H is 01000100 and the value of binary value of I is 01001001. Similarly, you have a binary value of exclamatory mark as well. So that means each and every character is converted into such short strings and 8-bit strings of ones and zeros, and all these strings put together is called as a data code, and this data code is actually transmitted from one system to another system, and when it reaches the destination, it is basically decoded and it is reconstructed back to the original message. Now there are different types of data codes which are available. The first type is called EBCDIC. Now EBCDIC stands for Extended Binary Coded Decimal Interchange Code. This was predominantly used in IBM AS400 systems. Then you had ASCII. ASCII stands for American Standard Code of Information Interchange. Now here each character in an ASCII code is represented by a 7-bit character set containing 128 characters, which means it goes from 0 to 127. So if you think of your keyboard has got multiple characters, and each character on a keyboard is represented by an ASCII value. Now for example, A has an ASCII value of 65, and similarly you have an ASCII value for a delete key, a backspace key, and so on. So you have around 127 characters which are represented by ASCII, but unfortunately these 127 characters are not sufficient, because earlier there was only English language for communication between two systems, but today as the internet is so developed, you have got various other foreign languages coming into picture. Earlier you had only text for transmission, but today you are transmitting text, you are transmitting emojis, you are transmitting various other things. So 128 or 127 characters will not be sufficient for you to basically transfer the data. So in that case, people came out with a new data code mechanism called Unicode. Now the Unicode stands for Universal Character Coding Standard. Now what exactly it is? It assigns a code to every character and symbol in every language in the world. So I've got many foreign languages, and for all the foreign languages it will basically assign a character and symbol in every language, which means that it is basically comprising of a 32-bit character set, and it has 21474836447 characters, which means 2,147,483,647 characters are there in Unicode. So Unicode is predominantly used in internet today. Now that you have understood what are data codes and how data codes are actually used for transmission for data from one system to another system in a computer network, we shall look into some of the terms which are basically used in computer system and networking, and one term which we commonly use is called as a frequency. Now putting it straight together, if you ask me the scientific definition of a frequency, I would simply say frequency is the number of cycles per second. So what exactly is one cycle? A cycle is a combination of a positive half cycle and a negative half cycle. Now you can see here a positive half cycle ranges from 0 degrees, go to the 90 degrees, comes to 180, and the negative half cycle varies from 180 to 360. Now one positive and one negative half cycle makes one cycle. So over a given time of 1 second, there are two such cycles which are shown in the picture here, which means that the frequency is 2 Hertz, because there are 2 cycles per second. So if there are 3 cycles per second, then the frequency is called as 3 Hertz. So like this you can basically determine the unit of frequency, and the unit of frequency is Hertz. Now knowing the frequency, there are different levels of frequency. You have something called a low frequency, or a medium frequency, or a high frequency. Now, the low frequency could be a less number of cycles per second, whereas a medium frequency could have moderate number of cycles per second, and a high frequency could have high number of cycles per second. So that's pretty straightforward. You can understand what is your low frequency, medium frequency, and high frequency. Now that you have understood frequency, which is actually predominantly used in analog transmission, we should try and understand what exactly you mean by a bit rate. Now the bit rate is nothing but number of bits per second. The bit rate is basically used for digital transmission. Now have a look at this particular picture here. Now I'm transmitting this value 1001101. Now how can you transmit this 1001101? This is transmitted in the series of voltage levels. So if I want to transmit 1, it is represented as an positive 5 volt, and if I want to transmit 0, I have to represent that in a voltage instance of negative 5 volts. So positive 5 volts will basically represent 1 and negative 5 volts will represent 2. Now the time taken to transfer one particular bit is called as an bit interval. That means when you look at this picture here, I am transmitting 10110001, which means that I need 8-bit intervals to transfer this particular data in 1 second. So 1 second will basically comprise of 8-bit intervals. So I can say the bit rate is 8 bit per second. So now that you have understood what is a frequency and what is a bit rate, now the bit rate is predominantly used in digital transmission, and frequency is actually used in analog transmission of data. Now both these kinds of transmission will have an factor called attenuation. Now attenuation is very common both in analog and digital transmission. So what is attenuation? Putting it straight, it is the reduction of the signal strength. Now what do you mean by the reduction of a signal strength? Now when I start my transmission from point A to point B, assuming that this is point A and this is point B, I am transmitting the signal from sender to receiver. The strength of the signal would be very high at the starting point, and the intensity or the strength of the signal reduces. So this is a common phenomena which could happen for any transmission of data over a given distance. Now what is the outcome of attenuation or the reduction of the signal strength? Your actual information is lost. Now when your actual information is lost, the purpose of entire communication network could be defeated. So how do you avoid this? You need to avoid attenuation by adding repeaters. So what are repeaters? Repeaters are those which will basically amplify the signal to its original strength. So we shall see what are repeaters in the later sections, but right now understand that attenuation is a concept which there is a reduction of the signal strength during any network transmission, and it can occur in any kind of signal, either it could be analog signal or a digital signal. Now every signal transmission would have a noise. Now this is very important, because what is noise? Noise is an unwanted signal which interferes with the original message. Now you have a signal here. Now this is a pure signal. Now this signal will also have a noise. So when you are actually transmitting the signal actually gets embedded with the noise, or putting it the other way, the noise gets embedded in the signal. So when it is coming at the receiving end, you don't get the actual signal, you also get signal and noise. So it is important for us to eliminate the noise and consider only the signal. So we have a factor called signal to noise ratio, which is called as S/N. So what is the signal to noise ratio? It is the ratio of signal power to the noise power, and it is expressed in terms of decibels. So there are different types of data networks. For example, you have a data networks where your recommended SNR would be 20 decibels, and for voice networks your recommended SNR would be around 25 decibels. Thank you for watching this particular session on data and signals. I will see you in the next session. Till then, take care. Bye bye.